Good afternoon, everyone. Thank you so much for being here. Glad you're in and hopefully dry, out of the rain. Before we get started on this OpenTelemetry Metrics talk, I wanted to see if we have anyone in here who was a mathlete in high school or majored in statistics or computer science or anything to do with math. Okay, excellent. Let's see a few hands. What is your name? Trenton. And who else just raised their hand? What is your name in the green? Me. Melissa. Melissa and Trenton. Okay, if there's any really hard mathematical questions at the end, I'm going to rely on Trenton and Melissa. Thank you guys in advance. Okay, so, hold on one second. Oh. Am I doing something wrong? So sorry. One moment.
So, you press these. Is it pairing? We love technology.
We love technology when it works. Okay, well, that's okay. I can just use, I'll just use my keyboard.
Okay.
Okay, now that I've identified my Q&A assistants, we can go forward. Okay, so my name is Reese Lee. I am a developer relations engineer at New Relic. I started out in tech support, and I mentioned this because I really enjoyed working with end users directly to help them troubleshoot issues and enable them on our products. So when I joined the OpenTelemetry engineering team at New Relic, and I was exploring the community and trying to figure out where I could best contribute, I landed on the OpenTelemetry end user working group. We have two overarching goals. One is to increase the adoption and implementation of OpenTelemetry. If I can say OpenTelemetry at once. And the second is to improve the project by facilitating and maintaining a constant feedback loop between end users and the project maintainers. So we're still working on that piece, but to that end, some of the activities that we host are things like a monthly end user discussion group where end users get together and talk about their user journeys and problems and questions that they're facing as they implement OpenTelemetry. We also usually have at least one or two members of the governance committee or a project maintainer on the call as well to help provide additional insight and context on the project. At the end of each month, and also these discussions, in case you're from a different part of the world, we have them available in all regions. So we have them for Americas, we have them for Asia Pacific, and we also have them for EMEA, which is Europe, Middle East, and Africa. So if you're interested in attending one of these sessions, we do have them available. And then at the end of each month, we summarize the discussions onto a blog post that you can find on the OpenTelemetry blog. So you can go on there and see example topics of things we've discussed in the past. Some of the other things that we host, there's a monthly OpenTelemetry in practice where it's an hour-long session and we have different speakers come on and talk about OpenTelemetry in practice. We also conduct end user interviews where we speak to a specific team or individual who is implementing OpenTelemetry in their organization to learn more about the user journey and also get feedback. So if you're interested in any of these resources or if you're interested in contributing to the working group, definitely please come find me, or you can also find more information about them on the OpenTelemetry.io site. Okay, I'm also going to share a few fun facts about myself. So I'm not just a talking head up here and a weirdo who matches her earrings to her slides. I am originally from Malaysia. I've lived in the Pacific Northwest for going on 20 years now. And every year I have thought, oh, this is the year I leave to find somewhere warm that my tropicalness is more used to. But then I bought a house, So go figure. I am kind of stuck there now. I've also submitted Mount Hood, which at 11,249 feet is the highest point in Oregon and the 4th in the Cascade Range. And I've also visited 14 countries. I'll also be speaking at KubeCon EU. I'm not sure if any of you are going there, but if you are, let's connect there as well. And I'm hoping that number will be at 17 by the end of next month. 18 if I can squeeze Pearson. We'll see. OK, I've summarized or categorized the content of my talk into 4 broad sections. We're going to start with a metrics overview. We'll talk a little bit about OpenTelemetry. We'll go into the meat of the session, which is called metrics dip, and I'll explain why it's called that when we get there. And then we'll close out with a recap and some suggestions on what you can do next to explore further on your own. OK, so we're going to start with a metrics overview. Specifically, we're going to start by answering these 2 questions. Oh. What is a metric, and why are they useful? What is a metric? A metric is a measurement about a service that's captured at runtime. These measurements can be further aggregated over time to help us identify trends and patterns. Metrics is also a very broad term, right? It can be used to encapsulate different categories of metrics, such as infrastructure metrics, application runtime metrics, business and custom metrics, and all of these are useful to different teams within a given organization. Throughout this session, I'm going to use the OpenTelemetry community demo application as the basis for our examples. It is an online shop selling telescopes. You might be familiar with the GCP online boutique shop. This is basically the same thing, except we are selling telescopes because observability. So with this in mind, what are some examples of metrics you might want to collect from this application to help us understand the health of the application? So first off, we've got the traditional golden signals, so things like latency, traffic, errors. So we want to collect throughput, response time, error rate. We are probably interested in resource utilization, so CPU and memory usage. We probably also want to collect some user data, such as number of active users, total process orders of a specific items. These are all examples of metrics. Why are metrics useful? So there's really 2 questions here. One is, why are metrics useful for observability in general? And what are the characteristics of metrics that make them more useful than the other 2 main telemetry signals, traces and logs? So in general, all 3, metrics, traces, and logs, are used to help us monitor the performance of our application. As far as data visualization, span data can be used to power certain graphs and charts. But in general, metrics are much better suited and also more widely used for powering graphs and charts. Since numbers are optimized for storage, processing, compression, and retrieval, that makes them really well suited for enabling longer retention of data, as well as easier querying. So this makes them really great for building dashboards that reflect historical trends over time. Metrics are also really useful when it comes to helping us reduce the volume of data while still providing insight into that data. We use metrics because it can be really expensive if you're exporting and analyzing measurements one by one. Another reason why metrics are useful is because they form the basis for service level indicators, or SLIs, that measure the performance of an application. These indicators are then used to set service level objectives, or SLOs, which teams use to calculate error budgets and consequently use for alerting. OK, if you're here for this talk, I presume you've at least heard of OpenTelemetry, and some of you may be even more familiar with it. Maybe you've done some hands-on stuff with instrumenting applications, and you want to learn more about implementing metrics in OpenTelemetry. Whatever the case, I'm excited you're here. And just so everyone's on the same page, we're going to do a refresher by answering these questions. What is OpenTelemetry? And why OpenTelemetry for metrics? OK, what is OpenTelemetry? OpenTelemetry is, ding, 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 an observability framework built on an open standard. It formed as a result of two existing open source projects that merged together, called Open Census and Open Tracing in 2019. And it is now the second most active CNCF project in terms of contributions after Kubernetes. So that should give you an idea if you are less aware of OpenTelemetry than some other people might be. The project aims to standardize how applications are instrumented and how telemetry is generated, collected, and transmitted. How does OpenTelemetry do this? It does this by providing a set of language-specific APIs and SDKs, tools and components such as the collector, instrumentation libraries, semantic conventions, and a protocol called OTLP, or OpenTelemetry Line Protocol. So the Astronomy Shop application that we're using as a basis for examples is composed of several microservices written in different languages, including Java, .NET, Python, Ruby, that talk to each other over gRPC and HTTP. With OpenTelemetry, we have one standardized set of tools that we can use across all these services to instrument, generate, collect, and export telemetry. You can then forward that data onto a data analysis tool of your choice. You could even configure different pipelines for each signal. So you could send your metrics to one backend and your traces to another, and then your logs to another still. Why might we want to use OpenTelemetry for metrics? So I'm going to answer, there's probably a lot of answers for this, but I'm going to answer this question by talking about the design goals of the project. So the first is being able to connect metrics to other signals. For example, we can correlate metrics to traces using exemplars. We can also further enrich attributes, metric attributes via baggage and context. Another one is providing a path for Open Census customers to migrate to OpenTelemetry, which, if you recall, was one of the original goals of OpenTelemetry when it merged with Open Tracing. And third, one of the design goals was for it to work with existing metrics instrumentation protocols and standards with a minimum goal of providing full support for Prometheus and SATS-D. The biggest benefit of OpenTelemetry for you as an end user, though, is part of the fact that it grants you freedom from vendor lock-in. You can instrument your application once and send your data to whichever backend you would like, open source tooling or a proprietary service. And you can do that simply by changing your exporter endpoint. So pretty cool. OK, metrics dip. This is what we are going to cover in this section. I'm going to go over the session scope. We're going to talk about metrics and OpenTelemetry. We are going to look at the architecture of a metrics pipeline. And then we're going to look at metric instruments, types, and use cases, where we'll answer the questions, what is an instrument? What instruments does OpenTelemetry provide? Why is instrument selection important? And how do I choose an instrument? OK, so I want to explain why I'm calling this section metrics dip. It's a play on the term deep dive. So it's, rather than putting on a scuba suit and going deep diving into the giant lake of metrics, we're really just dipping our feet in the water. There's so much more to learn about metrics. Some of the topics we cover here could really be their own full sessions. There's also some things that I don't cover here, it being a 101 session. But I do have a list of topics that I recommend for further exploration at the end. And I also have a list of reference material that I consulted to put these slides together. So you will have some next steps at the end. I've tried to make this session so that you have a solid foundation for understanding metrics as they apply in observability using OpenTelemetry, and hopefully enough to get you started. Excuse me. OK. So metrics in OpenTelemetry are separated into the API and the SDK. The API is used to instrument code. So application owners can use the API to install pre-built instrumentation for their frameworks and libraries. The SDK is used to implement the API. And you can also use the SDK to configure what happens to the telemetry that you collect, that is collected by the API. Oh, including processing and exporting it to a platform of your choice. The meter provider is the API entry point for metrics. The meter provider gives us meters, which can be used for different scopes, a scope here being a logical unit of application code. So for example, an HTTP client library would have a different scope and therefore a different meter than, say, a database client library. You can use these meters to obtain instruments, which are what we use to record measurements, which will consist of a value and a set of attributes. The SDK provides implementations for all of the above, the meter provider, the meters, and the instruments. The SDK is also responsible for aggregating the measurements reported by the instruments and exports them as metrics following the configurations that you've set. OK, now we're going to talk about some metrics concepts as they apply in OpenTelemetry at a high level. A few of these we're going to tie together when we talk about metric instruments. And then there's a couple here that we kind of just talk about on this slide, but are important to mention for reasons I'll explain shortly. So the first one is aggregation. Aggregation is a process of combining multiple measurements into a single point. So a very simple example would be you have a set of 30 values. Each value represents a daily total of sales of one of your telescopes. You could aggregate all these measurements into a single point, in this case, a sum, and that would be an example of aggregation. Next, we have temporality. The notion of temporality refers to whether the reported values of additive quantities incorporate previous measurements or not. And there are two flavors of temporality. Oh, wrong way. We have cumulative temporality, which refers, which indicates that measurements are accumulated when they're exported. Another way to look at it is it always has the same start time, except if your application restarts, in which case it resets to 0, and then the start time would be the new time of your application restart. You also have delta temporality, which indicates that measurements are reset each time it's exported. Or another way to look at it is you see the change, the reported change, instead of an absolute value. And yeah, another way to look at it is it has a moving start time because it's resetting each time it exports. We also have something called monotonicity. And this refers to whether the value is always increasing, which is monotonic, or always increasing and decreasing at the same time, or non-monotonic. The next two concepts I'm going to talk about, we won't get into beyond this slide for brevity and scope purposes, but it's pertinent to mention for reasons that will become clear in a second. The first is dimension. dimension in this context refers to an attribute that's associated with a metric. So let's say you are using an instrument to count the number of active users to your telescope shop. And you want to record some information about these users. Let's say their location. So the location will be added as a dimension on that metric. Dimensions are useful because we can use them to aggregate our data in different ways, and we can also use them to filter the data. The next concept I want to mention is cardinality. So cardinality is generally defined as the number of unique elements in a set. In monitoring, it refers to the uniqueness of a value in a set. So going back to the example I was just using, which is we're counting the number of active users to our application, and we're adding as a dimension their location. Let's say we decide to use their country as a location, and our users happen to all be from the same 1 or 2 countries. That would be a low cardinality value. If you use, if you're tracking the city of your users, and even though your users are from like the same 1 or 2 countries, if they're from all over those countries, the city would now be a high cardinality value. So we won't, like I mentioned, get into the topic of like adding dimensions or really discuss cardinality further, but I felt it was pertinent to include these concepts because managing cardinality is typically a topic of concern when you're collecting telemetry because of the challenge of increased storage cost. And also suppose you suddenly were inundated with high traffic to your application. Maybe you're running a sale on your telescopes, and now you have users from all over the world that are coming to your site to buy these amazing telescopes. If you're tracking the city of all your users, this is going to increase the load in your system and cause cardinality explosion, which I like because it sounds very dramatic. But some backends impose cardinality limits on your data, which can result in your data getting dropped. So it's something that's important to consider when you're thinking about implementing metrics in your system. OK. Now that you know a little bit more about the behind-the-scenes pieces of OpenTelemetry, of metrics in OpenTelemetry, let's take a look at a basic architecture of a metrics pipeline. So you already know a little bit about the meter provider. We use it to get meters, which we use to create instruments. And then the instruments are what we use to record measurements. From there, they're collected by a metric reader. And then the metric exporter translates the data into various output formats that we can then use to forward to a data analytics tool. One thing to note here is that the meter provider uses a default no-op implementation in the API. This allows app developers to instrument their code without worrying about the details of how metrics are generated. But it does mean that if you forget to implement the meter provider in the SDK, no metrics will be generated. This is a pretty common gotcha when you're using OpenTelemetry. But now that I've told you, you will all remember this, and this won't happen to you. All right, now we're going to get into metric instruments, types, and use cases. What is an instrument? Instruments are used to report measurements, and each one will contain the following fields: instrument name and kind, which are required, and then you also have 2 optional fields: measure of unit and a description. What instruments does OpenTelemetry provide? OpenTelemetry provides 6 instruments. You could say 4, since 2 of them are async versions of the same thing, but we're going to be thorough and say 6. We've got the counter, up-down counter, async counter, async up-down counter, histogram, and gauge. I'm going to have a few columns in the middle here. We'll go over them one by one. That indicate, these indicate the properties of each instrument. So the first one is the is whether it's synchronous or asynchronous. I was going to attempt to say synchronicity, but I can't get it. OK, so whether an instrument is asynchronous or not, an instrument is classified as synchronous when an instance of it is called when an event that's being measured occurs, such as when a user clicks on an element that's being observed. On the other hand, asynchronous instruments will only report a measurement once per specified interval. You'll also know that in the documentation, async counter and async down counter are also referred to as observers. And when you're creating the instruments, or the asynchronous instruments in your code, I'm not sure if it's across all languages, because I haven't tried it in all languages, but you'll see observable in the instrument creation method. So that maybe will help you remember which one is which. And whether or not you want to use a synchronous counter or an asynchronous counter is really up to you. Like, is it important for you to access data at the point of instrumentation or on a set interval? The next property we are going to look at is whether or not it's additive. So this is maybe self-explanatory. Additive just refers to whether the measurements are summed up or summed together or not. And the third property is the monotonicity of the instrument, which you'll hopefully remember from what we just talked about, refers to whether the values it records are always increasing or increases and decreases at the same time. The last column here, we have the aggregation strategy, or simply aggregation, for each instrument. These refer to the metric type that is produced by these instruments, and they reflect the intended use of the measurements. OK, so keeping the list we just went over in mind, why might instrument selection be important? So just now we learned that each of the instruments has something called an aggregation strategy. And they each come with a default aggregation that reflects the intended use of the measurements that they report. The instrument type we select determines how the measurements are aggregated, and ultimately the type of metric that is exported, which impacts the way you can query and analyze it. So we can look at it from a slightly different way, which is that different aggregations support different modes of analysis. For example, maybe you want to analyze the latency of search results when people are searching on your websites for a specific telescope or some other stargazing equipment. You would want the format of these measurements to be such that you can obtain this insight. So thinking about this, a sum of these measurements wouldn't make sense because you can't really get anything useful from that value. What you would want is a histogram that gives you a distribution of response times. Thus, you would want an instrument that can produce a histogram. Here's a brief framework for how to choose an instrument. So first, think about how you want to analyze the data. Second, do you need the measurement synchronously, or can it be reported, or does it make more sense to report it on a set interval? And third, are the values monotonic, which means is it always increasing, or does it increase and decrease, fluctuate at the same time? OK, we are going to take a closer look at each of the 6 instruments, when you might want to use each one, and a few example use cases for each of them. First, we have the counter. In OpenTelemetry, a counter is a monotonic instrument that only supports increasing non-negative values. So using our telescope shop as an example, some of the things you might want to use a counter for are things like total orders processed, total cart adds, total checkouts, total checkout failures, so on and so forth. Some other things that counters are typically used for are things like number of bytes sent, total requests completed. So you would want to use a counter when you want to count things and compute the rate at which things happen, or when the sum of the things is more meaningful than the individual values. An example of what a chart might look like would be that. So what about when you want to measure something that fluctuates, that goes up and down? This is where the up-down counter comes in. It's basically a non-monotonic version of the counter that can handle negative values. And some examples of things you might want to use it for are number of open connections, number of active users, because obviously that will change. You would hope that it would be monotonic, but reality is probably it's going to be non-monotonic. Queue size, memory in use. And yeah, so you'd want to use the up-down counter when you want to process positive as well as negative increments. An example of what a chart might look like would be that, where it goes up and down. So there's also, as you learned earlier, there's async versions of both the counter and the up-down counter. The async counter is just an async version of the counter. Some of the things you might want to use it to measure are things like CPU time, cache hits and misses, total network bytes transferred. You would use this when you need a sum of your measurements, but they are either too expensive to report synchronously, or maybe it's more appropriate, or you would just prefer to have it record on set intervals. Similarly, the async up-down counter. So you would want to use this when you need a non-monotonic additive counter to report on set intervals. Some examples of when you might want to use this are for memory utilization, process heap size, number of active shards, changes in the number of active users. And it would look pretty similar to what we saw earlier. Sorry, I thought there was another note that I wanted to add about this, but I think we're good. OK. So the counters are great for if you want to sum together the values of things, but what if you want to do other things to the data? HISTOGRAM also provides a histogram, which, if you have been paying attention, histogram in this case refers to both an instrument as well as an aggregation. Histograms and OpenTelemetry support two kinds of histograms. The one that it defaults to is the explicit bucket histogram, which just means that the buckets are explicitly defined ahead of time. So example usages would be things like HTTP server response times, client duration, request rate. And you would want to use a histogram when you want to analyze the distribution of measurements to identify trends, or when you want to calculate the min, max, and average of something. And so what we would see is essentially a distribution that looks something like this. Well, too fast. So I just wanted to touch on exponential bucket histograms real quick. They're pretty cool and powerful. I have a recommended reading if you're interested in learning more about that. They're similar to histograms in that they have buckets and bucket counts, but instead of predefining explicitly the bucket boundaries beforehand, the boundaries are computed on an exponential scale. There was one more thing I wanted to mention about the explicit bucket histogram. Apologies. So typically, when you're using a histogram, if you have values that fall outside your upper bucket boundaries, those data points are not captured. But OpenTelemetry provides a mechanism where values that are outside of your maximum upper boundary are captured in an additional bucket. So one thing to note is that a histogram can also be additive, but the emphasis is on recording data when a distribution of values is the main priority. The final instrument that OpenTelemetry provides is called a gauge. It's an async, non-additive, non-monotonic instrument that sends you a last value. Some examples of things you might want to use it for are CPU utilization, temperature of hardware at this point in time, or average memory consumption. You would want to use a gauge when you want to report data that's not useful to aggregate across dimensions, and you have access to the measurements asynchronously. Or when you want to have finer grained control of when a non-additive measurement is made, particularly when its purpose is a distribution. So looking at our little example chart here, if you're collecting, say, the temperature of your hardware at a given time, you could collect more specific data points to give you more granularity, but if what you want to do is analyze the overall average, you don't necessarily need all the incremental changes in the temperature over time. In OpenTelemetry, the gauge as a data point can never be incremented or decremented. It's only ever set to the value that's being recorded. I've heard that a synchronous gauge has been proposed. Just as an FYI, I'm not really sure where that is at the moment, but if you have a specific use case for one, you might want to look into that. Okay, now that we've talked about instruments, I want to take us real quick back to this slide where we talked about the fields that an instrument contains. This would be an example of when you want to create an instrument, the instrument name. Let's say you want to measure the total telescope sold. You would give it an instrument name such as telescope sold. And you would want to use a counter. And you could have an optional measure of unit, which would be telescope. Now that we've talked a little bit more about the different instruments, there is something else that OpenTelemetry provides called view or views. Consider that some of your applications may generate metrics that you're not interested in, or you want to change the default aggregation of an instrument. Views provide SDK users with the flexibility to customize the metrics that are output by the SDK. Some examples of when this might be needed are if you want to process or ignore certain instruments. For example, maybe you have an instrument in a library that provides both temperature and humidity, but you only want the temperature. You can also use views to customize the aggregation. If the default aggregation that's associated with the instrument that is being used isn't meeting your needs, for example, an HTTP client library might expose HTTP client request duration as a histogram by default, but if what you want is a total count of outgoing requests, obviously a histogram is not going to be useful for you. You can also use views to filter on attributes. So for example, an HTTP server library might expose HTTP methods and status codes, but you might only be interested in one or the other. You can use views to customize all of this, which is pretty cool. OK, what is next? We'll do a quick recap, as well as talk about some next steps for you. Here's some of the things that we talked about today: what a metric is, why they're useful for observability, what OpenTelemetry is, and the utility and some of the customization options it provides in metric generation and collection, metric concepts as they apply in OpenTelemetry, and we also went over OpenTelemetry metric instruments and how to choose one. And I also have here a consolidated table of, there we go, of the 6 instruments that are provided as we went over them earlier. And as I mentioned earlier, we have only dipped our toe beans in the lake of metrics. Here is a suggested list of topics that you can look into to learn more about metrics. The first thing I usually recommend is just try it out yourself, instrument an application, and implement metrics and send them to some tooling of your choice. Views API we just talked about, I recommend looking into that more. You can look into data point types, adding metric attributes or dimensions, push versus pull-based exporting, which OpenTelemetry supports both of those. And you can learn more about the different kinds of metrics, as well as the metrics processors that are available if you're using the collector. So finally, I have some credits and references. I see I have an extra bullet point. Oh, that really bothers me. So thanks to Jack Berg of New Relic and VJ Samuel of eBay for providing some assistance when I was creating this slide deck, and some of the wonderful materials that I referenced that I recommend reading as well. Thank you.